Hi Falcons! Today we are going to be investigating physical properties of matter, and we are going to be testing each item to see about its mass, to see what state of matter it's actually in. Testing and observing, not just testing. And then we're also going to determine whether or not these items are insulators or conductors by using some wire and a buzzer and a battery. Okay, so let's get started. If at any time during the video you would like to pause, feel free to go ahead and do that so that you can fill out your template here on Seesaw. I'm going to show you what your template is going to look like. It's going to be something like this. Okay, now let's get started. We'll start with the penny. We'll start with the mass. Anytime that you try to determine the mass using a triple beam balance, you want to start by having all of these weights on this beam down to the zero end. Okay, your item is going to go on top of this circular flat piece, and what we want to look for is that these two lines match up evenly. Notice we have a zero, it's got a little line beside it. There's a line on this beam right here. And once we adjust these weights on the beam, then this is going to move. And we want it to balance right on the zero. So let's see, the penny, I don't think I need to start with the hundreds. And I'm pretty sure I don't need to start with the tens. I'm going to start with the ones. If I'm wrong, I can always go back and change it. See how it moves. I'm in between 2 and 3, and if you notice here, the beam is below the zero. So that means I've gone a little too far. I want to come back a little bit. So let's go ahead and come back. It's still below the zero, just a tiny bit. Let's come back a little more. And a tiny bit more. Sometimes it's kind of hard. You have to be very patient because the beam wants to go below the zero and back up, and then below just a little more and back up. So you have to kind of step back and not touch it until it gets finished moving, and then you can observe. Looks like we have it balanced now, so let's check the number. Okay. This number gram is at 2. It's not really in between 2 and 3. It's right on the 2. So the penny has a mass of 2 grams. So if you'd like to pause the video and go and fill in 2 grams on your template, then you may do that. It'll look something like this. Okay. Now let's get the mass of the binder clip. Let's push everything down to 0. Go ahead and set the binder clip on that circular flat piece. Now, before we get too hasty and go ahead and just start jumping in and moving these weights to try to find the mass, it's always good to stop and think about a prediction. What do you predict is going to be the mass of the binder clip? I mean, we have something to compare it to. If the penny was 2 grams, do you think this binder clip is going to have more mass than the penny or less mass than the penny? And if so, just how much? Okay, so let's take a look. Oh, 2 is not enough. 3 is not enough. Oh, now we're getting close. I'm in between 4 and 5. Ah, and it looks like it is balanced. Okay, if you look closely on a triple beam balance, you will see tiny little lines in between the whole numbers. There are 10 little lines in between those whole numbers, and those are our milligrams. There are 10 milligrams in each gram. Okay, so in order to write that correctly, we wouldn't just leave off that little part. We wouldn't just say it's 4 because it's not just 4 grams. It's a little bit more, but not quite 5. So that's when our milligrams come in handy. And the way we write the milligrams is by using a decimal. And you've talked about decimals in math, and this is one place where they come in handy, where you'll use what you've learned about decimals. Since it's the 4th mark past the 4, we would write that 4.4. And the actual way that you would say 4.4 is 4 4/10 grams. So the binder clip was 4 4/10 grams. Pause the video and go add that to your template. And now let's go ahead and get the mass of this piece of cork. Again, make your prediction. What do you think? Is it going to be close to the mass of the binder clip? More or less? Close to the mass of the penny? More or less? Let's take a look and see. Sorry about that noise. That was out in the hallway. Looks like I need a tiny bit more maybe. Okay. Now, something interesting about this piece of cork is that it's not quite to 1. So we can't say it's 1 gram. So what do we have to do? We have to count those tiny little marks. What were those called again? That's right, milligrams. Let's see how many milligrams is our piece of cork. Okay, it's the one right before the 1. So if there are 10 milligrams to 1 gram, and it's at the very last milligram before the 1, what is that? If you said it is 9 milligrams, you are correct. Now, since it's not a whole number yet, it's not a whole gram yet, we're going to show that it's not a whole gram yet by using our decimal. We're going to place the 9 not in front of the decimal, but behind it. So there are really 0 grams, but 9 milligrams. And the way that we write that is we go ahead and put a 0 in the ones place. We put our decimal, and we put our 9 in the tenths place. And the way you would read that is that it's 9/10 of a gram. So it's almost a gram. We have one more thing to get the mass of, and that is this styrofoam cup. Let's put these back at 0. Place the cup on the circular part. Now, notice, this time, maybe I'm going to go ahead and start with the 10s. Let's see what happens when I go to 10. Oh my, it goes all the way down. So I know that 10 grams is too much. So I'm going to push that one all the way back to 0, and that's when I move down to my 1s. Okay, I'm in between 3 and 4, and it has gone below the 0, so that's when I know I need to pull back a little bit. Bring it back a little bit. It's coming up some, still has a ways to go. so 3.0 was not right. 2.9 is a little much. Let's see what 2.8 does. Ah. Oh, that's still a little too much too. Ah. When I put it right back on the 7 tenths there, then it balanced. So the mass of the styrofoam cup is 2 7/10 grams. So that would be written 2.7. Okay, so 2.7 grams for the styrofoam cup. Now we've gotten the mass of all of our items. We have two more properties to test. Let's go ahead and talk about the state of matter. It's on the far right of your template. So what's the state of matter of the penny? Solid, liquid, or gas? Binder clip. The cork. Whoa. Well, cork went away. And the styrofoam cup. So you can actually go ahead and fill in what is the state of matter for each of these items. So I'm going to stop this video and start another video. So you'll turn to the second video to find out about whether or not these items are insulators or conductors. See you in a few minutes.